Hello everyone, this is Devabrata and welcome to our channel Schrödinger Smiley. Basically this channel is built for the class 11 and 12 standards for basically the NEET aspirants and JEE Main and Advanced. We just discussed here the physics for NEET and physics and mathematics for JEE Main and Advanced, and we have the another channel, the Schrödinger Scat, is basically the for the BSc and MSc students for aspirants CSIR, NET and IIT JAM. So let's get started. We have just fundamental discussed here the play with the graphs. Basically we have the introduction topic, the play with the graphs. We have the three another chapters, basically introduction to graphs, curvature and transforms, curve tracings, algebraic and polynomials, rational, irrational, piecewise function, and another is transcendental function, trigonometric, exponential, logarithmic, inverse of exponential, geometrical, and last but not the least is inverse trigonometric. And basically sometimes the visual understanding of a mathematical problem is quite helpful in solving in fast and correctly. Play with graphs is an attempt to ease the minds of the mathematical lovers and the engineering aspirants who wish to solve the tricky and knotty mathematics problems involving functional approaches. This lecture help you make intuitive connections between the graphs of the functions of the problem with an exact solution of the problem, and it always help to discuss the properties of the various standard function with the help of their graphs and later takes of the tasks such the curvature of transformations, asymptotes and the singular points. Finally, the idea of curve tracing. So go ahead, our first topic is basically the polynomial functions. So for polynomial functions we should plot here that we just know the graph plotting of y equal to x and y equal to x square and x cube and others on. So we just generalize these equations here that we just plot the graph fx equal to x to the power 2n and x to the power 2n minus 1. Basically one thing is that the x square, the even one, the even function is here, the even function is basically x to the power 2n and it is symmetrical about y axis, symmetrical about y axis, and the odd one is x to the power 2n plus minus 1 is basically symmetrical about origin or opposite quadrant. So first one we should draw the x to the power 2n. So basically for fx is x to the power 2n where n belongs to capital N, the range is basically the r belongs to x belongs to a range minus 1 to minus 1 union 1 to infinity. And here we just plot, this is origin x axis and y axis, and this is basically y equal to x. So y equal to x square, this one, and y equal to x to the power 6, this one, basically x square, x to the power 6. So this range is minus 1 and this one is 1, and for this method we just get y equal to x square, x to the power 6 and dot 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 x to the power 2n. So another one is basically for the odd one and the odd functions, basically the fx x to the power 2n minus 1, and for this we just plot here that the x belongs to 1 infinity where x less than x cube less than dot dot, and for x belongs to 0 1 basically x greater than x cube greater than dot dot, and this one our x origin x and y, and this one is y equal to x, and for x cube we just plot here that this one y equal to x cube, and for x to the power 5 this should be like that. Just follow the bending. This one is x to the power 5. So dot dot dot, we just plot here the x to the power 2n minus 1. So now go at our next topic. This type is basically for the polynomial graphs, and the other one basically the rational numbers and the rational graphs, basically fx in the form of 1 by x to the power 2n and 1 by x to the power 2n minus 1. And for this one we just take into account that for fx equal to 1 by x to the power 2n minus 1 is basically that this one is odd function, so it becomes symmetric about origin, first point, and as limit x tends to 0 plus fx, and this is for y tend to plus infinity, and limit x tends to 0 minus fx is basically for y equal to tend to minus infinity. And the graph would like to see is that this is basically the y equal to 1 by x plot, and this one is for, this is origin, this is x and y, and this for 1 by x, and this for 1 by x cube. So dot dot dot, we just plot the general form that 1 by x to the power 2n minus 1. Go ahead our next, that basically the even function fx 1 by x to the power 2n. For that this is even function, and so basically it would be the symmetric about y axis. So this one is origin, x and y axis, and the 1 by x square is basically like that, and x to the power 4 like that. This is basically 1 by x square, x to the power 4 dot 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 1 by x to the power 2n plus 1. This is basically one thing is that range minus 1 minus 1 to plus 1 is range. So basically we just draw the graph in the principle of range and the domain of the function, and the symmetric about origin or y axis. Let's go ahead our next discussion for the irrational functions. Basically we have the irrational functions like that x to the power 1 by 2n and x to the power 1 by 2n minus 1 for n belongs to capital N. So first one is for the odd functions, first one for the even functions, x to the power fx is basically 1 by x to the power 2n, where the domain and the range x belongs to closed interval 0 to infinity, and basically we have the graph like that. This one is origin and this one is x and the y axis, and basically formally this is the y equal to x straight line passing through origin, and we just plot here for the x square. Earlier we just plot this one is x square, this one is for x to the power 4 x square x to the power 4, and symmetric, so this one would be x to the power 1 by 2 and x to the power 1 by 4. So go ahead our next, the odd one. We just derive calculate for the short times of interval fx is basically 1 by x to the power 2n minus 1, basically the odd functions. So we have the origin, the x axis and the y. This is basically passing through origin, and this one is x cube x to the power 5, and the another one is for that 1/3 x to the power 1/3 x to the power 1/5. So dot 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 x to the power 1 by 2n minus 1. So go ahead our next topics, the piecewise functions. Basically graph for y equal to mod x, signum x and the box x and the list This is basically boxes and the greatest integer function and the least integer function, or the greatest integer function or stepwise function or 4 of x. So first one is for the y equal to mod x, basically this one and this one is mod x plus x, and we have the definition y equal to mod x is basically the x where x greater than 0 minus x less than 0, and this is for plus x and this is for minus x, this is for y and origin and the x. So its range r belongs to 0 to infinity. So another one, the signum x, basically y equal to SGNX. So we have defined SGNX is basically mod x by x or x by mod x, otherwise 0 for x not equal to 0 and for x equal to 0. So basically 1 for x greater than 0, minus 1 for x less than 0, and the 0 for x equal to 0. So its domain would like that, domain belongs to R and R belongs to range minus 1, 3 value 0 and 1, and the graph would like that 0, this is origin x and y, this one is 1 and this one is minus 1. This is the graph of the signum x. So basically our third one is for the greatest integer function or stepwise function or 4 of x, basically defined as y equal to box x, and so box x define 0 less than equal to x less than 1, 1 less than equal to x less than 2, 2 less than equal to x less than 3. This is our define, and we just plot the graphs here that this is origin x and the y, and the another one is basically this one. This one is 1, this one, 1, 2, 3, 4, similar symmetric like that. This one, this one, this one, this one. This is the box x. And the another part, that basically the fractional functions is defined as second bracket of x is basically x for 0 less than equal to x less than 1. This is fractional function x minus 1, 1 less than equal to x less than 2, x plus 1 is basically minus 1 less than equal to x less than 0. This is for the fractional function, and we have the graph plotting like that here, that 0, this is the x and the origin and the y. So this one is 1, and graph would like that for the fractional function, this one, symmetric in negative quadrant. This should be in this type, this should be this, basically here 1, 2, and this is the graph for the fractional functions. And go ahead our next topics, the least integer functions. Opposite of greatest integer function is defined as y equal to first bracket of x is defined as that minus 1 for minus 2 less than x less than equal to minus 1, 0 for minus 1 less than x less than equal to 0, 1 for 0 less than x less than equal to 1. So the plot would be like that. Basically this is origin x and the y, and plot would become in the form of that this one, symmetric about this, basically this one, and this one, and the point 1 2 3, and here -1 -2 -3, and this is for the least integer function. Go ahead, our next part, basically the transcendental function, and first one we just discuss here the graph for sin x, cos x, tan x, cosec and sec x. You just know the range and the domain of the graph. So basically here for deducing we just first write the domain and the range for fx equal to sin x is basically the range -1 to 1 and the domain R. For the cos x, R belongs to -1 1 domain R. Tan x is range belongs to -infinity to infinity. Basically range means the tan x value of x is defined within the -infinity and the infinity, and the domain is like that, basically R minus 2n plus 1 odd multiple of pi by 2. This is the domain of the tan x. So basically, and here we just plot very simplicity, and we have the another part, this some geometrical curve. So basically for doing this one is origin and the x and the y, and the graph would be like that. And this one is pi, this one is 2 pi, minus pi, minus 2 pi, and the second one is for the cos x, y equal to cos x. Basically for cos x, that this was the x-axis origin, and the graph would like that, this one, and this value pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, and the third one is for the tan x, y equal to tan x, and the graph would like that, this one is axis, this one origin x, and the y we have a section part, this one, but in the equal distance, this, and the graph would passing through origin, and this one is another, and that one is another. Very important is that the cutting point, this one, and this is basically pi, and this is for minus pi. So we have deduced sin, cos, tan x, and you just for homework the reverse of the functions cosec x, sec x, and cot x. Go ahead, our topics here, the graph for exponential function and logarithmic function. So basically for exponential and logarithm function, that first one is for the fx a to the power x, basically range 0 infinity and domain R. The graph would like that, this one is x, origin x, and the y, and basically we have this type of graph. this one and that one. This is a equal to x general form. Suppose we have 2 to the power x, a equal to 2. Another one, that 3 to the power x, 4 to the power x, dot 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 a to the power x. Second one, we just deduce that log x. So basically y equal to a to the power x, so x equal to log y, and x equal to log y, and the x belongs to R and y belongs to domain and the range 0 to infinity, and basically this one is the graph. This is 1 0 where a greater than 1, and the another one like that. This one is 1 0, and so basically upper half increasing upward when a greater than 0, increasing downward when the range 0 less than a less than 1. So our next topics is that the geometrical curves, and geometrical curves is like, you also know in your mathematics, parabola, hyperbola, ellipse, ellipsoid, hyperboloid, paraboloid, and we just not draw here, and we just straight line, circle, parabola, like that. You all know and familiar with that. Here we just deduce the rectangular hyperbola, the equation x square minus y square equal to a square is basically, and the small form, compact form, xy equal to c square, and the graph would like that, this one and that one. This is the origin and x and the y. So basically we go ahead. Our next topic, basically the inverse trigonometric functions. So formally the graph of the sine inverse x, cos inverse x, and tan inverse x. To deduce this one, we just consider here, first one is y equal to sine inverse x. For sine inverse x, that x we just write minus 1 and 1, and the y range and the domain minus pi by 2 and pi by 2, and we just know the graph of sine x. For this concept we draw the sine inverse x. This one is for sine x, point pi to 0, and this one is y equal to x straight line, and for sine inverse x we just plot like that. This one for y equal to sine inverse x. So for second one is basically y equal to cos inverse x. So for cos inverse x, the range 0 to pi and the domain d minus 1 to 1. You know the graph of cos x like that. We have choose another this quadrant, similar like. So this one is cos x, and for cos inverse x the graph would like that, this type of graph. This is 1, and this is for y equal to cos inverse x. Similar for the another coordinate. And third one is that for y equal to tan inverse x. So for tan inverse x, the range r belongs to minus within first bracket minus pi by 2 to pi by 2. Another one is domain is basically belongs to r, and you just know for this one the y axis, origin x and the y, this one is portion, so another portion. So you know the graph of tan inverse x basically is like that. This one is this graph is for y equal to tan x. For tan inverse x, we just draw by the concept of the range at the domain that graph would like that, this quadrant. Just very careful. This would be the pi by 2 and this is the lower half section, that minus pi by 2, and this one is for y equal to tan inverse x. So basically you just some small homework, y equal to tan of tan inverse hyperbolic tan x 1 2. Just do this homework. Go ahead our next topics, the applications of the main graph, that the trigonometric inequalities. So here the question is that sketch the graph tan x less than 2. So tan x less than 2, here we have period t equal to pi and the interval r belongs to minus pi by 2 to pi by 2, and that for deduce that here minus pi by 2 less than x less than tan inverse 2. So minus pi by 2 less than x less than arc tan 2, arc or amplitude. Basically the general solution would like that 2n pi minus pi by 2 less than x less than 2n pi plus tan inverse 2. So n belongs to 2n pi minus pi by 2 and another one is 2n pi plus arc tan 2. So arc of tan 2 is our final answers, and basically to draw this inequalities we just plot this is and that one, this is for origin and x and the y, and basically sections like that, this one, and we know the value of tan x, the graph of tan x would like that, this one. This one is y equal to tan x and range 0, here that one is pi by 2 minus pi by 2. Here we just tan 2 arc 2, so basically this straight line is y equal to 2, and so arc tan 2, this graph would like that, this is cutting point and this is x equal to tan inverse 2 or arc tan 2. So the tan 2 graph and this point, this section would not happen after this line x equal to tan inverse 2 equal to arc tan 2, this line would not be in tan x less than 2. So y equal to, we have graph y equal to tan x, and for tan x less than 2, this part is cutting out for the tan x graph, and we get the inequality tan x less than 2. Go ahead, our next topic, basically the curvature and the transformations, and we have another part is one important, that we have no y equal to sin x or sin inverse x, and if we do plot that if we do plot a one graph that y equal to sin inverse sin x, this would become, here the time period is 2 pi, and for sin inverse sin x is basically the x for the minus pi by 2 less than equal to x less than equal to pi by 2. Another one is pi minus x, where pi by 2 less than equal to x less than equal to 3 pi by 2. So basically, which is defined for the interval with length 2 pi. So this one is x origin and the y, and this is the line and that one, and so basically pi minus x, so straight line up and down with m or tan theta is basically the slope minus 1, and in the range of minus pi by 2 and the pi by 2 is basically, here this one is pi by 2 and minus pi by 2. So plotting this, that pi minus x is a straight line, so this one is for the y equal to x, and that one another, so dot dot dot. This one is the graph of the y equal to sin inverse sin x, and this one is y equal to x, and that one is y equal to pi minus x. This will be the graph of y equal to sin inverse sin x. For simplicity, you just homework that y equal to tan inverse tan x, after that tan of tan inverse tan hyperbolic x. You just plot these two graphs. So next one is the curvature and the transformations. For doing this, the sketch the graph y equal to x minus 1 into x minus 2 into x minus 3. So this is application of the play with the graph and the called drawing the graphs. So first one, we just y equal to 0. So put y equal to 0, we get value x equal to 1, 2 and the 3. So after simplicity, we just get x cube minus 6x square 11x minus 6. Second one, do first derivative dy dx, basically 3x square minus 12x plus 11. Second derivative d square y dx square is nothing but 6x minus 12. So now first derivative would be 0 by the condition, get the value 6 plus minus root 3 by 3, and third one is that we get the value dy dx x 3x square minus 12x plus 11. Put the value of x here, that x minus 6 minus root 3 by 3, another one x minus 6 plus root 3 by 2. Basically this one would be the 3, and after we just get 2 point that x less than 6 minus root 3 by 3, basically the x greater than 6 plus root 3 by 3, and after numerical value this quantity would become 1.42 and that one become 2.58. that draw this graph. This one is origin, and on line origin x and the y axis, and this one is basically the maximum portion and the minimum portion here. So basically the 6 minus, so this one is minus 6. So basically we have the value that 1.42 and 2.58, basically range 1 to 3, the fx within the 1 to 3. So that we just plot 6 minus, to 6 is starting point, the value of this one is 1, So one thing is the going upward direction or maximum point when upward direction or maximum point when the x less than 2, downward tracing when x greater than 2, so downward. Ultimate the minimum point would touch and now is increasing. This one is 1 and that one is 2, that one is 3. This point is basically 6 minus root 3 by 3. That point is formally 6 plus root 3 by 3. And another thing is that it is for x less than 2. We just saying that for x less than 2, here in this finding value for x less than 2, the curve within the range, and after 2 x greater than 2, this portion. So in this process, here we apply for x less than 2 or greater than 2 condition. This is called the concave or convex property. Concave or convex properties is saying that for concave going upward when x greater than 2, downward x less than 2. Concave property is basically the derivative and the second derivative or third derivative. We just put the value of first derivative equal to 0 and put in the second and the third and check whether it is will be positive or the negative. Now we just go at our next topics, final topics, is basically the curve tracing. And curve tracing is nothing but the parametric equation, and we just draw a curve like that. Here we just have sketch the curve of a parametric equation, theta dependence, x equal to a into theta plus sin theta and y equal to a into 1 plus cos theta. Here in the range of the x basically belongs to minus pi to pi, and we just draw a table that theta is x and y, and this table, and this is for minus pi, 0 to pi, and basically here for x value we just get the result minus a pi, and for 0 value get the result 0. Put the value of pi here, we just put theta equal to pi, we just get the value of a equal to a pi. And another one is for y equal to 0, we just get the value of, for minus pi the y value would become 0. For theta equal to 0, get y value 2a, put theta pi, get value of y is basically 0. So this one is that minus pi less than equal to theta less than equal to 0 dx d theta, that a into 1 plus cos theta, and dy d theta is nothing but minus a sin theta. So dx d theta first order derivative is 0 if theta pi and minus pi. Also for theta equal to plus minus pi and x equal to plus minus pi, basically here we just conclude here the property of concave and convex property, and it's saying that the first derivative and first one is basically the fx function f dash x and the x double dash x. So first one is the function like fx is equal to 0, put fx equal to 0 is a function given, and we just take the first derivative and put the value of in the second derivative and check whether it is the positive or the negative. So like that the maximum and minimum conditions, and here we just plot the third order, basically the singular points and the asymptote for considering second one, basically xy, and for plotting this curve tracings like that origin and the x and the y is basically here that one main important thing, that the value minus pi to theta to 0, that xy starting from minus a pi 0 moves the right hand upward 0 to 2a. So this one would become 0 less than equal to theta less than equal to phi, vice versa. And the point xy starting from 0 to 2a and moves to right and downward of the a pi 0 except the value of minus plus pi. This was the conditions. I think you just understand these things. And also tangent at theta equal to pi and minus pi, just put first derivative 0, we just get the dx d theta is basically 0. অতএব suppose the m tan theta at is equal to theta equal to pi and minus pi, we just get value for theta equal to plus minus phi, the value of x is plus phi and minus phi, just a minute, minus phi, and the curve going starting from minus pi 0, this minus pi 0 and the pi after just this one. So basically here the curve starting from xy, this is minus a pi 0 or a equal to 1 and moves right and upward to 0 to 2a. Basically that would be the characteristic of the parametric equation x equal to a into theta plus sin theta and y equal to a into 1 plus cos theta. So basically here I just give you the same time of homework and you just understand for your exam point of view. This is basically helpful for your JEE Main and Advanced Physics and Mathematics and NEET Physics, and I usually give homework for your better understanding and clearing of concepts. So here homework is just sketch the graph for tan inverse 2x by 1 minus x square. Second one, draw the graph of the function y equal to sin x by x. Plot mod y is equal to mod log mod x. Sketch the graph of the y square into a plus x into x square a minus x. Parametric equations of Cartesian coordinate, and sketch the graph of x cube plus y cube equal to 3x square where a greater than 0. Basically you pause the video and take a screenshot here. And third one is this contact. Formally that solve this homework, and if anyone needs these files and like the study material of my YouTube lecture, just mail with this ID without any hesitations, catschrodingers1935@gmail.com. Basically this name is associated to my second channel Schrödinger's cat, is basically for BSc and MSc students, for aspirants of IIT JAM and CSI and NET. Last but not the least, thank you very much. Stay happy. Goodbye. Take care.